Hello friends, in one of the previous video we have seen how to apply Newton's law on an inclined plane when the friction is absent. Now in this video we will see how to write equation of motion when there is a friction on the inclined surface. And this we will illustrate using a problem. So the objective of this session is to calculate the angle of inclination. In other words, what is this angle alpha for the given problem. So this problem says, let us consider the toboggan as shown in the figure. So this is the toboggan. The incline has coefficient of kinetic friction mu k. So the coefficient of kinetic friction for this incline is given and this is mu k. The slope has just the right angle to make the toboggan slide with a constant velocity. So this angle is just right so that this toboggan is moving with a constant velocity. This means this remains in equilibrium. So in other words, we can apply Newton's first law. So question says, find this angle in terms of W, that is the weight of the toboggan, and friction coefficient, that is kinetic friction coefficient mu k. So how will you solve this problem? So let us first write the things that is given. So we have been given weight of this toboggan, that is W, coefficient of kinetic friction, that is mu k, and the angle alpha we have to find, that is my target variable alpha. And we have been also given that this toboggan is moving with a constant velocity. So this toboggan is moving with a constant velocity. So how will you solve this problem? So since this is a case of equilibrium, we can apply Newton's first law and then we can write equations and we can solve these equations. So let us first draw the free body diagram for this toboggan before applying the Newton's law. So this is the toboggan. What are the forces that is acting on this toboggan? So one force that is acting is the weight. So let us show here. So one force acting is the weight. So I can show something like this. So this is my inclined surface and this angle is alpha. It does not matter whether I show like this or I show like this. So this doesn't matter because this is, we are, as long as we are considering all this inclination and angle, so it will not have any difference in the problem. Now what are the other forces? One force, that is normal reaction. So normal reaction will act in this direction. Any other force? So this try to move in the downward direction. So this is trying to move in the downward direction with a constant velocity. So this surface will try to oppose this motion. To oppose this motion, the surface will apply a friction force that will act in the upward direction. And this friction force is F and this will be mu k times N. Since this object is moving with a constant velocity, this friction will be kinetic in nature and that's why we have taken mu k times n, not mu s times n. In this problem also mu k value is given. So we can use mu k times n to calculate the friction force and this will act in the upward direction. So magnitude of friction force is mu k times n and the direction of friction force, this will act in the upward direction. Now whenever you have a problem on incline, you have to basically decompose the forces along the incline, that is my x-axis, and perpendicular to the incline, that is my y-axis. So in this case, I have to decompose my forces along the incline and perpendicular to the incline. So this force is W. So this is W. So I have to take the component. So in this direction, this will be W cos alpha because this angle is also alpha and this is W sin alpha. Why this angle is alpha? Because there is a theorem that says angle between line is equals to angle between perpendiculars. So this line and this line, on this line this is the perpendicular and on this line this is the perpendicular. That's why this angle is alpha. So once I have taken the component, I have to basically remove this force and we simply put a bigly sign so that now we are not going to consider this W. Now let us write equation of motion. So first we will write equation of motion in the x direction. Since this is in equilibrium, that is moving with a constant velocity, sum of the forces in the x direction is equals to 0. So what are the forces that is acting in the x direction? One force is mu k times n, that is acting in the upward direction, that is positive direction, and this force that is in the downward direction minus w sine alpha, this is equals to 0. That is sum of the forces. So this is my equation 1. Similarly, we can write sum of the forces in the y direction is equals to 0. So in the y direction we have normal reaction, and this force that is w cos alpha, that is in the negative bidirection, so minus w cos alpha, this is equals to 0. That is my equation number 2. So you can see these two equations can be used to solve for alpha. So let us using equation 2 calculate value of n and put into the equation 1. So from equation 1 we can write mu k, and n that will be coming from this equation, that is nothing but w cos alpha. So mu k times n minus w sine alpha, this is equals to 0. So from here I can calculate alpha. So w cancels out, so we will have mu k is equals to tan alpha. So I can write tan alpha is equals to, so this tan alpha is equals to mu k. One important observation you can say, this angle alpha does not depend upon the weight of the toboggan, that is W. So it does not depend upon the W. So you can have a smaller toboggan or you can have a larger toboggan. In both cases it will move or it will slide with a constant velocity for given friction, and it will not matter at the same angle, it will basically slide. So you can also write alpha is equals to tan inverse mu k or arc tan mu k. So alpha you can also write arc tan mu k. Now you can see if your mu k value is higher, then alpha will also be higher because tan inverse is a increasing function. So if mu k is higher, alpha has to be higher. In other words, I can say if alpha increases, mu k increases, or if mu k increases, alpha increases. In both directions we can see. This basically makes a sense because if you consider this inclined plane, if you increase angle alpha, then in that case, if you want to move this toboggan with constant velocity, you have to increase your mu k. Otherwise, it will accelerate. If mu k value is not that large, in that case, it will start accelerating. So if you want to move with a constant velocity and you are increasing alpha, in that case, you have to increase mu k. So if you increase, or if you can make a steep inclined plane or inclined surface, in that case you have to make the surface rough also, so that you can have a constant velocity. So in this video we have seen how we can calculate angle of inclination alpha for a given value of coefficient of friction, that is coefficient of kinetic friction, and these two are related by a function of tan inverse. You can use this problem to solve or to calculate the angle for given mu k value. So I hope you enjoyed this video, and if you enjoyed, please share with your friends and like and subscribe this channel. I will see you in the next video. Thank you.